Good morning, everyone. Myself Devika, working as assistant professor in the Department of Electrical and Electronics Engineering at Sri Muthukumaran Institute of Technology. Today, we will learn about the subject on Basic Electrical and Electronics Engineering. This is a subject for second semester 2025 regulations. In this presentation, we will discuss Introduction to Alternating Current Circuits and its components. Introduction to AC circuits. So alternating current or AC is a type of current that changes its direction and magnetic periodically with time. So AC is widely used in homes, industries, and commercial buildings because it can be easily generated, transmitted over long distance, and distributed efficiently. Most electrical appliances such as fans, lights, refrigerators, and air conditioners operate using AC power. Voltage in AC circuits. In AC circuits, the voltage supplied by the source is generally sinusoidal in nature. So, its sinusoidal waveform repeats itself after a certain time interval called a time period T. This periodic variation of voltage causes the current in the circuit to also vary with time. So del V is equal to del V max sine omega t. Omega is an angular frequency. We know that 2 pi f. F is a frequency. So the frequency to complete one revolution, one complete cycle taken the time. Time taken for complete one cycle. So F is equal to 1 by 2. So we substitute in this equation. So angular frequency omega is equal to 2 pi f or otherwise 2 pi divided by t. The voltage supplied by an AC source is sinusoidal with a periodic time t. Next, resistors in AC circuits. When a resistor is connected in an AC circuit, the voltage and current remain in the same phase. This means the voltage and current reach the maximum and minimum values at the same time. So, resistance only opposes the flow of current, but they do not cause any phase difference. So, the voltage and current is in same phase. So, del V minus I or R is equal to 0. We know that according to Ohm's law, I is equal to V divided by R. Here, changing voltage with the time. So, del V divided by R equal to del V max sine omega t divided by R. We know that del V divided by R is equal directly proportional to current. So I max, del V max is directly proportional to I max. So I max sine omega t. Next, RMS current and RMS voltage. AC circuits, we often use RMS. RMS means root mean square values of current and voltage. So RMS values represents the effective value of AC current or voltage which produces the same heating effect as a DC current. The term RMS stands for root mean square. So meaning the square root of the average of the squared values. Inductors in non-AC circuit. In non-inductor, the voltage and current are out of phase by 90 degrees. That means pi by 2 radians. This means the voltage leads the current. So the opposition offered by an inductor to AC is called inductive reactance, represented by XL equal to omega L. So here omega is angular frequency, L is a inductance, XL is a inductive reactance. So in this circuit, AC voltage is applied to the inductor. So del V is equal to del V max sine omega t. We know that this equation. So here by applying KVL, applied voltage is equal to sum of all dropped voltage. So here applied voltage is 0 equal to del V plus del VL. So del V minus, we know that according to voltage across the inductor is equal to L into DIL divided by dt. So substitute these values in del VL. So del V equal to L into DIL divided by dt equal to del V max sin omega t. Then capacitors in an AC circuit. In a capacitor, the current and voltage are also out of phase by 90 degrees. But in this case, current leads the voltage. 90-degree leads the voltage. So the portion offered by the capacitor to AC is called capacitive reactance. So represented by Xc equal to 1 divided by omega C. Next, RLC series circuit. An RLC series circuit consists of a resistor, inductor, capacitors are connected in series across the AC source. The total impedance of the circuit depends on resistance, inductive reactance XL and capacitive reactance XC. So the RLC circuits are widely used in filters, tuning circuits and communication systems. Thank you. Hope this presentation helped you understand the basic concepts of AC circuits and their components.